This presentation discusses some recent changes in the storage plan for the clean rooms in the Jefferson Lab Experimental Equipment Lab. Because of the tight schedule, this information is being provided in video format to minimize confusion and distribute the information as quickly as possible. The specific areas that are discussed here are the EL-124 cleanroom, shown on the left, and the EL-125 cleanroom service area, shown on the right. The current contents of these areas include the CLAS-12 Region 3 drift chambers, a CLAS-12 Region 2 drift chamber, and 4 CLAS-12 Region 1 drift chambers. The cleanroom area also contains the CLAS-12 silicon Vertex tracker, micromegas, and supporting materials. The back section of the support area is largely filled with the CLAS-12 forward tagger system and materials associated with the HPS experiment. There are also some general Hall B materials distributed throughout the room. The next major project to be conducted here is the assembly of the ring image Cherenkov or rich detector. This assembly was originally planned to enter through the rear door of the EL-124 cleanroom and occupy that space until June 2017. Due to schedule changes, though, the forward tagger assembly will block the rear entrance for the foreseeable future, and the cleanroom space will need to be shared with other ongoing activities. This presentation will show a revised layout for the space, the sequence of operations that will be performed, and will discuss some concerns that were identified in developing the model. The image shown here shows the EL cleanroom and supporting area as it is populated at the beginning of August 2016. By the end of August, the CLAS-12 Region 1 drift chambers will be relocated to Hall B, where they will be installed. The Region 2 drift chamber will follow shortly thereafter in September of 2016. This will vacate a significant amount of space at the front of the cleanroom service area and give us the opportunity to create a clear path to the front access door. This will be accomplished by consolidating the forward tagger materials in the back of the room and then removing and storing the hodoscope, dry boxes, and other miscellaneous materials that have been placed in the room. To prevent further unplanned incursions during this process, areas near the forward entry will be secured with rope stanchions. In early September, the silicon Vertex tracker will be relocated to Hall B for short-term testing. During this time, it will be necessary to rearrange the Region 3 drift chambers in the cleanroom to support future activities. Although this appears to be a minor change, it allows the silicon Vertex tracker to be returned to the room for continued assembly and for the Region 3 drift chambers to be removed easily. In late September, the silicon Vertex tracker will be returned to the cleanroom and will be located in the back of the room where it's accessible by the gantry crane. The electronic enclosures and supporting equipment must be positioned so that the crane can roll into position over the silicon Vertex tracker and still have 2 meters of crane-accessible space to install the micromegas. It is advisable for the installers to position the crane first before configuring the supporting materials in order to ensure that there's adequate space and clearance. This brings us to October 2016, where we will begin to receive the bulk of the material related to the rich detector. While this material was originally planned to enter the cleanroom immediately, the delay in installing the Region 3 drift chambers will prevent that. As a result, the materials associated with the rich detector will be stored in the secured area immediately outside of the cleanroom. This allows them to remain in a climate-controlled area while still providing access to remove the Region 3 drift chambers. By the end of November 2016, the Region 3 drift chambers should be relocated to Hall B. This frees the EL-124 cleanroom to begin the rich assembly process. It should be noted here that this cleanroom has been in continuous use for CLAS-12 assembly for several years, and because of that, material related to several aspects of the project have accumulated in the room. Before beginning rich assembly, it's advisable that all unnecessary materials be removed from the room and either disposed of or stored for future use. The rich assembly process will begin with the erection of the detector assembly structure. This will be located near the airlock to the cleanroom so that both it and the SVT assembly will be accessible by the gantry crane. Once the assembly structure is complete, the rich detector frame will be brought into the room. It should be noted that this model suggests that the rich detector will be an extremely tight fit when moving through the access doors. The measurements of both the detector and the access path should be confirmed before this work is started so that alternatives can be considered if necessary. Once the rich detector has been attached to the assembly structure, the gantry crane will be used to pivot it into position. Once in place, the detector will be secured and the gantry can be moved out of the way. Next, the rich assembly team will install a small darkroom in the back of the cleanroom where the mirrors for the rich detector will be assembled and tested. With the darkroom installed, the rest of the rich detector material can be brought into the room and the assembly process can begin. The viewer should note that this plan is based on our current schedule and priorities. Conditions may change, at which point this plan will need to be reviewed and potentially altered. For now, please plan activities based on this schedule and equipment configuration. If you have additional information, comments, changes, or concerns, please contact Walt Akers at Jefferson Lab.